Okay, in this presentation we're going to prove some logarithmic a logarithmic identity. Okay, so starting off here, what we have to do is show that the left hand side is equal to the right hand side. Now the left hand side I actually wrote on, I spread it out over two lines, but you get the idea. So log of x to the base 5 times log of y to the base 2 minus log of x to the base 10 times log of y to the base 5. What we have to do is show that that is equal to log of x to the base 2 times log of y to the base 10. So what I'm going to do is actually start off with the right hand side here. So I'm just going to start off with this bit here, log of x to the base 2 times log of y to the base 10. I'm going to let that equal a and that equal to b. Okay, so we have an expression here. I'm going to just rephrase the right hand side as a times b. Okay, so let's just push ourselves into that. So what I do here actually is let a equal to log of x to the base 2, and necessarily 2 to the power of a is equal to x. Okay, so what we're going to do is actually get an expression, get the logarithm to the base 5 and the base 10 of what we have there. Okay, so I'm going to get the logarithm of both sides of this expression here to the base 5 and to the base 10. Okay, so log of 2a to the base 5 equals log of x to the base 5. And I can just actually use the rules of logarithms just to take that power out and re-express that as a times log of 2 to the base 5. And similarly, a log of 2 to the base 10 is equal to log of x to the base 10. Okay, so we're going to use this expression here and this expression here. Okay, sorry, this expression here and this expression here. I'll just let that focus settle there. It's just awfully jumpy. Okay, now what I'm going to do actually is I'm just going to sort of cut to the chase. Actually, I'll speed this up a little bit. Okay, I'm going to do something very similar for the b. Let b equal to log of y to the base 10. 10 to the power of b is equal to y, and therefore we can say that b of log of 10 to the base 2 equals log of y to the base 2, and log b times log of 10 to the base 5 is log of y to the base 5. That's just actually using those very simple identities. Okay, so what we're going to do here is use this, and this, and just put them back into our equation. Okay, so let's just start onto the new page here. Just sort of go on to a new page. Okay, so there I've sort of rushed ahead there a little bit, but essentially what I'm going to do there is actually that's the left hand side. This is what the left hand side is equal to. Okay, and I'm going to rephrase each term there, or I'm going to substitute everything we've used on the last page. So log of x to the base 5 is a times log of 2 to the base 5, and so on. Okay, that's grand altogether. Okay, now we have different bases here. I have log of 2 to the base 5 and log of 10 to the base 2, log of 2 to the base 10 and log of 10 to the base 5. Okay, but what we can do here is, this is one of the laws of logarithms. Now I'm using p onto q just to not get us confused with anything else I'm using, because I'm using a and b and x and y. So just actually I'm going to use p and q here. Log of q to the base p is equal to 1 over log of p to the base q. Okay, so if you invert it, you can switch the two values there. Okay, so this is an important step here now. I'm going to rephrase log of 2. I'm going to try and get everything here on this entire expression in terms of log to the base 2. Okay, and so I'm going to so essentially what I'm going to do here is rephrase this as log of 1 over log of 5 to the base 2. Okay, so I'm going from here using this to getting this expression here, 1 over log of 5 to the base 2. Okay, similarly I'm going to do something here. I'm going to try and get this all in terms of log to the base 10. Essentially what actually happens here is 10 is the only value common to both sides. Okay, so that's why it's an informed decision. Okay, so what I'm going to do is actually pick out log of 10 to the base 5 and re-express that as 1 over log of 5 to the base 10. Okay, that's an important little point I should have pointed out. What is common here is 2 and 2, 10 and 10. Okay, that is big. That informed my decision as to what to do there. Okay, so we have AB times log of 10 to the base 2 over log of 5 to the base 2 minus AB times log of 2 to the base 10 over log of 5 to the base 10. Okay, so what we can do here is use the change of base formula. Okay, so log of P to the base R over log of Q to the base R can be re-expressed as log of P to the base Q. Okay, so essentially this expression here can be expressed as log of 10 to the base 5. This expression here can be expressed as log of 2 to the base 5. Okay, using that change of base formula. Okay, so I use that. Okay, and now we've broken the back of it essentially. So log of 10 to the base 5 minus AB times log of 10 to the base 5 minus AB times log of 2 to the base 5. Essentially, I'm going to just take AB out of it altogether. So I'm just going to sort of factorize it, so to speak, or simplify it. So essentially, log of 10 to the base 5 minus log of 2 to the base 5. That gives us log of, that's just using the division rule, the division subtraction rule. That is log of 5 to the base 5. That's equal to 1. So we have AB times AB log of 5 to the base 5 is equal to AB. And that's what we have to sort of start out with there. That's what we started out with there. And so that's what we have to prove. That is A at the start was equal to log of x to the base 2 times log of y to the base 10. That is our proof done. Okay. So again, now, just actually sort of remark, I just actually have it sort of both in shot there, above and below. This formula here was very useful, as was this formula here. So we'll leave it there.